All right, your title for today is Scale Drawings. It should just take one page, I believe. And this goes along with proportions, ratios, rates, unit rates, goes along with proportional reasoning, goes along with similar figures. It's all being able to set up the proportion properly. Go ahead and get that title written. Also, Scale Drawings. And don't forget, you can pause, fast forward, rewind anytime that you want to. So I want to talk a little bit about scale drawings first, how we use them in real life. A very large way that we use scale drawings is maps. This is a map. I just took a picture of my computer. You can see North Belton Middle School is right there. Here's Tarver right there. Here's Northgate. Bunch of new homes over there. Here's our new tennis courts and all of those baseball and softball fields are right over here. I want you to look at the bottom right. That is the scale factor. So that distance right there equals 1,000 feet. Okay, I'm going to see if I can. There we go. So that is 1,000 feet right there. So we could use that to measure somewhat how far things are. Oh, come on. Oh, it won't let me move. Uh-oh, what the heck did I do? Sorry. There we go. Okay. It won't let me measure. It won't let me pull that thing off of there. But we could use something to measure. That's the scale factor right there. That 1,000. I don't know why it keeps 1,000 feet. That would be what we mostly probably use it for. Something else that is very, very popular right now, especially around North Belton Middle School, is something like this. This is a drawing that an architect would have drawn on a piece of paper for a construction company to use to build a home, or this is a bathroom and a closet. So you can see it doesn't tell you the scale factor on here, but most of the drawings that I've seen, or blueprints, which is just a scale drawing, uses 1/4 of an inch equals a foot. Okay, so what has to happen is like a plumber, right, has to put in plumbing for the bathtub. They have to put a drain in and a water supply in the wall, which would be about right there. They'd put a water supply in there. They'd have a drain right there ready. And then over here for the toilet, they would have to measure and remember that this house isn't even built and they have to measure it. So they would have a water supply in right here, and then they would have a drain in the floor right there for the toilet. And then also over here at the two sinks, they would have to measure using this drawing. So the drawing has to be very, very accurate. The scale factor has to be very, very accurate. For this sink, in this wall, they would have to put a water line and a drain. And same thing for this one, a water line and a drain. So scale factor is very, very important. And drawings like this are very, very important. There's also a shower, which I didn't even see that shower. I don't even know how you get in that little thing. But it doesn't show it. I think this is the like water, what do you call it? The shower head or whatever. Okay, so we think about home building as like simple, right? You just see them explode up and they build them so stinking fast. But I want you to think about this. So this top drawing right here it would be like foundation work. So somebody comes out and tries to kind of level out the foundation and get it prepped. It's called site work, to get it ready for a home. So if you pay attention to the area around North Belton, you'll notice stuff like this first. They'll come out, they'll move dirt around, put some rock in, and then start building it on top of that. So on top of that, they put a slab, right? A concrete slab. Well, you don't see it right here. So think about that drawing from the bathroom. They put forms around a house, and it's this wood right here. Those are forms, and then they put plastic and rebar and metal and all kinds of stuff on the inside. So plumbers have to measure incredibly accurately because they have to put the plumbing in the ground first, then they pour the concrete on top. So there's some plumbing right here for a shower, maybe a sink. This may be for a toilet or something right there. And then right here there's more, which may be for like a water heater or something, because that red line is going up very, very high. So think about how accurate this plumber has to be, because think about it. They're going to build a wall where it's supposed to be, and that plumber has to get that plumbing exactly where it has to be. And it all started with a guy or a woman sitting at a desk drawing a drawing using scale factor. Okay, so scale factor is very important. From that point right there, you end up with something that looks like this, right? This is what you see over at North Belton. That's a concrete slab. You see all those things sticking up out of the concrete. There's a drain, some plumbing lines maybe. There's a drain, another one. And then this is obviously over here a bathroom, because there's a lot of plumbing over there. Same thing with this one right here. This is some kind of bathroom. And once you pour that concrete, you can't move that plumbing. So it's very important that the scale drawing was accurate, very, very accurate. And that these plumbers and electricians and framers and everybody else can really read a drawing that is to scale. Okay? So after all that, right? After this dirt work and after this plumbing gets stuck into the ground, it has to be so accurate that it can fit in the right spot in that little 2-inch by 4-inch board, okay, on the bottom. So all of this work has to be so accurate. The only reason I'm bringing this up is because some of you will use scale drawings when you're older, and so it's important that we understand why they're important and who uses them. All right, so let's get to our notes. Don't forget that you can pause and fast forward and rewind anytime that you want to. So scale drawings, it's just a proportional 2D drawing of an object. 2D means 2 dimensions. It can only have a length and a width. Okay, 3D would have a length, a width, and a height. That would be a model. But a scale drawing is a proportional 2-dimensional drawing of an object. So they're going to have a scale factor. The scale factor is just the ratio between 2 sets of measurements. Okay, it might tell you that 1/4 of an inch equals 1 foot in real life. Okay, and we'll talk about that here in a second. So that's just how a drawing is related to the real object. Okay, so let's get started. All right, so here's a drawing of a window. Remember, it's just a drawing, and the drawing is 1.5 inches long and 1 inch tall. It says that the scale is 1/2 of an inch equals 2 feet. So what are the dimensions of the actual window? Okay, pause this and write that down if you need to. So what do we have in our scale? We have 2 things in our scale. That's what we want to focus on. We have inches and feet, right? So we have inches and feet. Okay? So our scale, you can go ahead and create your proportion. Sorry. Our scale is 1/2 of an inch, 1/2, and 2 feet, and 2 feet. So let's find out the length of this. The length right here. That's in inches. So we want to find out how many feet that is. 1.5. Okay, now you can cross multiply. Right? We all know how to do proportions now, you cross product and then divide, get a different color, divide by what you have left. Okay, cross product 2 times 1.5. If you don't like fractions, you should know that 1.5 is just 1.5 as a decimal. So you can do 1.5 times 2. There's one decimal place in there. I'm going to put that there just to help me remember to put it in my answer. 2 times 5 is 10. 2, 3, and 1 decimal. So we have 3, and then divided by the number that's left over. 3 divided by 1/2, which I'm going to make equal 0.5, because I'm sure most of y'all like decimals better than fractions anyway. Make this into a whole number, so it's really 30 divided by 5, and 5 goes into 30 6 times. So the width, or the length, it doesn't matter what you call it. I'm sorry I didn't write that neater. So this equals 6 feet in real life, the actual window. Okay, so let's do that again for the this measurement here. We will do inches and feet, inches and feet. Set up my proportion. We know we have a half inch equals 2 feet, and on our drawing we have 1 inch. I'm going to do this one a little bit differently. We get from a half to 1 not by adding a half, but multiplying by 2, because 2 times a half is just 1. So we do the same thing. 2 to the 2 times 2 is 4. So the actual height is 4 feet. Okay? So all you have to be able to do is set it up properly. If you can set it up, that's number one. We know how to do proportions now. So setting up is the hard part, or the part that we need to focus on. Alright, so let's talk about a model now. So I drew a little truck here. I know that's pretty awesome. Remember, you can pause this and write this down before I keep going. So I drew a little truck there. That truck model is 5 inches long. So what is the actual length, or the actual size of the truck? So the scale factor is 1 inch to 7 feet. 1 inch equals 7 feet. Okay, so what two things are we talking about here? We're talking about inches and feet. Inches and feet. Okay, set up your proportion. Remember, you're given 3 out of the 4 items that you need. The first thing that we have is 1 inch and 7 feet. That's the scale factor. And then the actual, the inches in the model, is 5. Alright, so nice easy proportion here. Cross product what you can. Divide by the number that's left over. 7 times 5 is obviously 35. And 35 divided by 1 is 35. Okay, so the actual length of this truck, it's huge, is 35, 35 feet. Okay. I'll make another short little video to help you with some of your assignment. Remember, number one, set up the proportion properly. Okay. Cross product and divide. All right.